mathematicians. Today we're going to talk about monomials and factoring. First, a prime number is a number greater than 1 that has only two factors, 1 in itself, so it can only be divided by 1 or itself. List some prime numbers. 2 is a prime number. 5, the only thing that divides into 5 is 1 and 5. 3, 7, and the list goes on and on. Okay, so they can only be divided by 1 in itself. Composite, on the other hand, are all the other numbers greater than 1 that have more than two factors. So they can be divided by multiple values. For instance, 6, not only can it be divided by 1 in itself, it can also be divided by 2 and 3. About 15. It can be divided by 1 in itself, and it can also be divided by 3 and 5. We are going to write these numbers in prime factorization, meaning we're going to break it down into the prime numbers that multiply to equal the value. To do so, we are going to make a prime factorization tree. So I'm going to break up 180. And I always want to break it up very basic. So besides 1, does 2 go into it? 2 times 90. And we're going to circle any prime numbers. So 2 cannot be broken up anymore. So we circle it. How can we break up 90? There are a couple different ways, but if I just keep doing my 2's, 2 times 45. There are multiple ways your tree can look. In the end, they'll all be the same. So you might have a different path on your tree, and that's okay. Eventually, your answer will be the same. How do we break up 45? 5 and 9. Can I break 5 up anymore? Not besides 1 and 5, so it's done. What about 9? How can we break up 9? 3 and 3. Can we break 3 up anymore? No. So I'm going to look at the circled prime values. I have, and my smallest number is 2. So I have 2 and another 2, so 2 times 2 times, what's my next number? My smallest? 3 times 3 times, lastly, what's my last in the circle? 5. So I have 2 2's, 2 3's, and a 5 multiplied together. This is prime factorization. These are the prime numbers that divide into 180. If you were to multiply these together, you would get 180. Try 68 on your own. Let's see how you did. If I was to break this up as 2 and 34, can I break up 2 anymore? No, so it's circled, it's done. What about 34? I can break it up as 2 and 17. 2 is done. Can I break 17 up anymore? No. So looking at my circles, I'm going to write those prime numbers as multiplication. So I'll have 2 times another 2 times 17. And you always want to put those in numerical order to be properly written. Nice job. If we take a look at number 3, we're going to first break up negative 20, and then I'm going to break up these exponents in variables. So if I start with negative 20, I'm going to get rid of that negative. So if I take out a negative, I have negative 1 times 20. So negative 1's done. What can we break up 20 as? And there's a couple ways you can do this, but they will all get the same answer. I can break it up as 2 and 10. And which one of these is done? 2. How can I break up 10? 2 and 5. Are both of these finished? Can I break either of them up anymore? Nope, we're all done. So if I was to write this, start with our smallest, -1 times what? 2 times 2 times 5. So we took care of the -20. The last thing we have to do is write a squared. A squared is the same as a times a. There should be no exponents in our prime factorization, so I have to break that up as a times a. What about b to the 4th? Times b. And how many b's will there be? B to the 4th is 4 b's. Okay, so there should be no exponents. You're going to rewrite this as b times b times b times b. So all of this is our prime factorization broken down as basic as we can, and that is the same as -20 a squared b to the 4th. Try this next one on your own. Let's see how you did. How did you break up 38? 2 times 19. Can either of these be broken up? Oh, they are both prime, so we're done. So I'll have 2 times 19. Do I have to break up r at all? Oh, there's just one r. What about r squared? Or s squared? S times just 1t. So 38r s squared t is the same as 2 times 19 r times s times t. Nice job. The next thing we're going to talk about is greatest common factor, or GCF is how it is abbreviated. Greatest common factor is the largest number that divides evenly into both terms. It is also the largest degree of the exponent that they share. So if I want to find the greatest common factor of 12 and 20, one way we can do it is we can list all the factors of 12. So 1 times 12, and I'm going to put those apart because I'm going to slowly meet in the middle. And then I can go 2 times 6, 3 times 4. So those are all the numbers that divide into 12. If I were to do the same for 20, what would we start with? 1 and 20, 2 and 10, and the last one, 4 and 5. I am looking for the largest number that divides into both of these. Which one is the largest that's on both of their lists? 4. Everything has 1 in common, so we can't list 1. They both can be divided by 2, but greatest common factor means find the largest one. That is 4. Some people are really good at figuring this out in their head. Others like to have the list written out. Do what is best for you. If we look at number 2, 17d cubed plus 5d squared. 17 and 5. Can we divide those two by the same thing? No. Both of those are prime. So the only thing they have in common is d. This one has 3 d's. This one has 2 d's. What's the largest number of d's they have in common? 2. They both have 2 d's. This one has 1 extra, but they both have 2 d's. If you were to list those out, they both have 2. So d squared is the only thing these two terms have in common. Let's take a look at number 3. Let's start with 12a squared b, or 27a squared b. 27, we have 1 and 27. Can anything else go into 27? 3 and 9. We also have a squared b, so a times b. Now let's do the same thing for 15ab squared. We have 1 and 15. Can we divide 15 by anything else? 3 and 5. And let's list out its variables. A, and how many B's are there? 2. And what else? A C. We want the greatest common factor, so the largest that they have in common. So if I look at the numbers, they have things in common besides a 1. What is it? 3. So the largest number I can divide those both by is 3. Let's also look to see what variables they have in common. This one has an A, and that one has an A. Do they have any other A's? This one does, but not this one. So they only have one A in common. What about B's? They have one B in common. This one has 2, but this one only has 1, so they only have one B in common. And do they have C in common? Nope, so I cannot put it here. They do not have C in common. So they both can be divided by 3. They both have at least one A, and they both have one B in common. Nice job. Try this next one on your own. Let's see how you did. When you started with 15, D cubed S. List out the factors of 15. 1 and 15, 3 and 5. And what did you do for D cubed? D cubed is 3 of them, and S, just 1. Now 5D squared S squared. How did you list out 5? 1 and 5. D squared, D and D. And S squared, 2 S's. Find the greatest thing they have in common. The largest number they have in common is 5. Do they have any variables in common? There's one D they both have. Do they both have another D? Yes, so how many D's do they have in common? 2D. This one has one, but there's not a match here. And any S's in common? They both have an S. This one has another, but it doesn't have a partner, so they only have one S in common. So they both can be divided by 5. They both have 2 D's in common, and they both have an S in common. Nice job today, mathematicians.